Hello YouTube viewers, welcome to my show Camera Tuesday. In today's episode we're gonna follow our series about sound and we're gonna take a look at types of microphone. So let's dive right into it. Now first thing you have to understand the properties of sound. Sound is very different to light, and given the fact that we auto adjust to everything, we have auto gain basically, it makes it very difficult to understand. So let's simplify it. Now first thing you have to understand, sound is just vibration. So can we hear every vibration there is? No, hell no. So our vibration starts, basically audible vibration range starts from 20 hertz, basically the bassy end of the sound that you hear, that's in that low end, and then it goes to 20 kilohertz, that sharp sound when you hear when somebody increases their treble in a music or metal music or glass breaking or things of that nature, that goes in that sharp range, that very painful kind of sharp tone that you generally get from a kilohertz sound track, basically 20 kilohertz. So this is the range, basically the bassy end, the high end. Now if you increase, basically if you go above from 20 kilohertz, you end up in ultrasound. Now obviously you understand the fact that you don't hear ultrasound. Then there is also another aspect that you have to understand. If you're buying a headphone, if you're buying a basically subwoofer, you always see things like it's below 10 basically 10 hertz, 5 hertz. How the heck those can be there if we can only hear 20 hertz? You have to understand this aspect. Basically sound is pressure wave. Now if pressure wave is slow enough and large enough, large being like if moving enough amount of air, it does make you physically move. Basically let's say you are in next to a concert speaker that is like 500 watt or 5 kilowatt, it's gonna physically move you because it's a air pump. Basically like 5 kilowatt of shockwave would be sent towards you. So that creates a problem that even though 20 kilohertz is the maximum audible range, if you go below that, you start to feel it. Basically that's why people always describe waves as doom doom, like you're feeling it because your physical body is reacting to it. So when you have a headphone that is so close to your ear, and if it's physically moving that kind of air, your ear is not hearing it, your ear itself is moving, and that your body feels. That's why bass is always described as, oh, that feeling, you feel the bass. That is why anything below basically 20 hertz, aka infrasound, is generally felt as a bass. Then we come to the most problematic aspect of basically sound is decibel. Now when engineers came along and like, okay, let's quantify sound, let's figure out a measuring unit, we realized very early on, because of our basically microphone, basically our ear, it auto adjusts. We have no original conception of how loud is, because our ear automatically adjusts the gain. So give you a context, we generally starts at 40. Basically if you are living in a very quiet environment, you will be below around 30. You will never go to 0 because your own body is making a lot of sound. So like your heart rate and everything, you have physical fluid moving through you actually make sound. So 40, let's start with that. Okay, 40 is that. Then we come to 60 we are talking. Now you might be like, okay, 40 to 60, that's not that big of a difference. Here's the deal, it's not a bigger difference because our ear has adjusted to it. If you have a microphone and that is sensitive to, let's say, 40 basically decibel, you set it to like 40 decibel and try to record a normal conversation, it's gonna fry it, because the energy level that we have now, it's very high, because decibel jumps in logarithmic. So basically 10, 100, million, 10 billion, it's like that. It's ludicrously fast growing. And then you come to 85. Basically if you are living in an area where you have 85 decibel and constantly exposed to it for like, let's say, 8 hours, you're gonna get blood pressure from it. So you have to understand it. If you are in a place where you are getting 85 decibels, try to find something, or please put a sound padding around you, because your physical health is in danger because of that. Then we come to the aspect, 90 decibel is your hair dryer. Now for small doses it cannot do much harm to you, but in long enough doses, as in like for whole day exposed to it, yeah, it's gonna cause some damage. Then we come to 105 decibel, helicopters, rock concerts. Then you go to basically 110 chainsaw and airport, it's very loud. Then we come to basically 120, that's jackhammer, and 140, that's bomb. That's the problem with a decibel scale, because if you think like, okay, 140 is a gum, how loud a nuclear bomb should be? Yeah, it's only 130 to 40, because logarithmically it's going up. So 150 is so loud it can set grass on fire just by the shockwave alone. At that scale, it's shockwave. It's not sound. No matter which frequency it is, it's not sound at that point. It's shockwave at that point. So a bomb only explodes at like barely 140, 150, and that's why if you watch any Mythbusters, they will always saying, 6 dB of pressure, 7 dB of pressure. dBs are very counterintuitive to understand. So you thought like 40 to 60 is a mild jump. Yeah, try that with a microphone and see how that happens. Because we are auto adjusting, because our ear have two layers of gain. Basically, there is a physical bone that tensions increases the tension on the membrane, that is directly controlling the setting, and then there is the electronic part, basically your software brain part. So these two things combined, we never actually understand it. That's why you can like talk to your friend. Let's say there is an imaginary friend here, and I'm talking with him on a park, and we started to move from park to a busy road. We can still maintain the conversation, we can still hear each other clearly. But if you had a lapel microphone like this, you will notice it, that person volume directly went up without even knowing it. We don't like, okay, now background volume has reached up 10 decibel higher, let's increase our volume to 11 decibel. That's not how it works. It's automatic, it's instinct level. So that is why we have to use decibel. The volume level on these things are very hard to understand. Please pay attention to this. Then this created a problem. Of course, your headphone cannot create 100 decibel, and your TV speaker can barely go up to, let's say, 70 to 80. Or you don't want a 100 decibel sound system because it will damage your hearing. So how do we make sure that we send signal to every device, from your mobile phone to your tiny earphone to your basically Walkman, all of them? How do we make sure it makes loud sound loud and quiet sound quiet? So we figured out something very ingenious, which we call basically 0 dB. So the idea is, instead of going from 0 to 10 to 20, we went from upwards down. So 0 simply means as loud as you can. Basically 0 on this device simply means as loud as the speaker can go. 0 decibel on this headphones means as loud it can go. 0 dB on this TV means as loud as it can go. Basically, one has output power of 1 watt, another has 2 watt, this has 40 watts. So that simply take care of that. 0 simply means as loud as you can. Basically, scream as loud as you can. So if somebody sends a 0 dB signal, software signal, digital signal, it's like, okay, 0 dB. Make the sound, simply it will try it as loud as it can. So that's how you can make sure, if you edit a movie and you're like, there is an explosion happening, you don't have to be like, okay, calibrate your speakers to 90 decibel and then do that. It's not gonna work that way. So simply we send 0 dB. So your TV screams as loud as it can, your headphone screams as loud as it can, your cinema theater screams as loud as it can. So that's why we inverted the scale. So, and many of you have this personal annoying experience when you're watching a movie, sound feels very low, and then basically advertisement comes in and bam. That bam happened because of this. So any sound engineer that is self-respecting, they will not even reach, let's say, -3 or -4. They will keep it as low as possible. They will keep it like -20 to -15. Now, of course, there are standards. There are European standards. There are American. So basically, they are on the low end. But when advertisement comes in, they go high. So that's why even though your TV volume was low, and if the signal was -20, you are like you're having a conversation. It's like nice, you're enjoying. But in advertisement happened, the signal from advertisement department was basically 10 dB or higher, sometime as high as like -6. So that will make your TV scream as loud it can in the volume that it already has. So it's not like your volume went up, it's simply because it's receiving a signal that's much more hot. This is what people classify as hot signal. So that's why it means like it's reaching to 0. You always want to be below that. So for YouTube video, people will say -6 to -12. For TV, because the TV have much higher standards, they will be like -20 to 24. And there is a whole lot of list that you have to go through to understand this. So this is the property of sound. Then we come to, okay, we understand the properties of the sound. Then what about the microphone? How do we actually convert basically physical analog vibration in the air into something electronic? We simply use microphones. There are two major types. There are hundreds of other types, but these two are the major type. First is condenser microphone, which is basically capacitor based. If you are not familiar with capacitor, you must have seen the capacitor drawing in basically your science book. It's basically 2 plates. That's what it is. When somebody says about condenser microphone, that's what they are referring to. There is simply 2 plates with a capacitive charge into that. So when air makes it vibrate, one will be fixed, another will be flexible. That flexible one will change the signal. Now that quote unquote signal can be voltage, sometimes it can be capacitance itself. Other people use other things. Basically that's what's changing, and that is why condenser microphone basically requires a voltage. You must hear this sort of phantom power, 24 volt, 48 volts. That's what there to charge it. It's not there. That's why like you can have a small portable recorder that can power basically this one can, Zoom H1 can, but bigger brother of this puppy can, because even though it has only 4 AA batteries, it does not need to do too much. It's just there to charge it. Basically once you charge it, it's done. It's just there to maintain it. So it does not consume like 50 watts of power. It does not consume power, but it does consume voltage just to stay charged. Now it has some pros, it has some cons, obviously. Then we come to dynamic microphone. Now what is dynamic microphone? Basically take your speaker and invert it. So basically, let's say you have a headphone like this. If you try to speak into this, especially the old one, don't try this with wireless one. If you have wired headphone, you can do this. Basically take the headphone out, speak into the earphone part, and change the cable there. It will work, but you will find out the volume level is very low. It's very, 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 very low. The volume level would be very low, because it's what we classify as moving coil. So of course it is a speaker, but it's inverted, and the physical dimension is made sure in such a way that it works at the loudness level required of it. Basically your headphone may be designed for, let's say, working at 10 to 20 decibel. Your microphone would be designed to work at 70 decibel. So these sort of things plays a crucial role. You can't just take a speaker and convert it into a microphone. You can do that, it will work, physically it will work, it just won't be very efficient use of space. So these are the two major types. Now there are many more types. There are carbon microphone, there is ribbon microphone, there is optical microphone, and laser microphone. So again, if you try to go online and try to buy a microphone, these are the first two things that you will come across. And you have to understand, many times people have this fixed view of the world and be like, condenser is better than anyone. Well, that's not true. Like each of them have their unique advantages, each of them have their unique disadvantages, and each of them play a crucial role. Basically they are tools. Now if you know your tools, basically you understand it, you will be like, okay, I do a recording in a recording studio, everything is very silent, yeah, I'm gonna use this. Now you might be like, okay, I'm a reporter and I go outside, there is a lot of background noise and there is a very high people speaking in very loud tones, and I want my equipment to be running on efficiently, battery powered, long running time, I'm gonna use basically dynamic microphone. So you have to understand, it's not like one is better than the other, it's just they are two different tools. Figure it out what you need. Then we come to the pickup pattern. So that's the first thing you're gonna choose, which microphone to have. After the microphone, you're gonna choose which pickup pattern to have. Now many times pickup pattern is also referred to as polar patterns. Don't think too much about it. Basically there is a few things about it. You have omnidirectional, you have figure 8, you have cardioid, you have hypercardioid, and you have ultradirectional. Don't think too much about it. Basically omnidirectional means a sphere of 300 degree sphere, and figure 8 simply means figure 8. And I have provided a video down below where they show you a very good three-dimensional video about it, and you will understand it much better watching that video. All you have to understand, omnidirectional is like this, what I am having here, so that's why I do not have to worry where it's pointed. Now anything that changes that, let's say you go to supercardioid, you have to worry how you pointing it. Benefit, it becomes directional. Now this is a very crucial aspect. This is a dynamic microphone. Now not this exact model, like many times people use dynamic microphone, and because it has a very unique pickup pattern, that's how that singer is able to speak. Because I already told you the decibel scale is kind of odd, so that singer or whatever talker you have, that barely you will be able to push 100 watts of 100 watt, I'm saying 100 decibel of sound. When he's screaming will barely get you to 120 if you're trying really hard and you want to die. Now, but when you have a lot of audience in front and you have giant megawatt size speakers that are blasting sound to them, this area is much louder. This area is like 120 decibel. How the heck that microphone can pick up like 100 decibel on top of 120? It does not. That is why we worry about this pickup directionality. So basically this side, this audience side is flat out silent to the microphone, because microphone built in such a way that it will not pick up sound from back, even if no matter how loud you make it. Of course you make it a nuclear bomb sound, of course it's going to physically destroy it, but within its reason, within its limit, it's not going to pick it up. That's how they can pick up the normal sound. That is why we worry about pickup patterns. Now in this sort of scenario, if somebody used omnidirectional, it won't work. If somebody has used a shotgun, it won't work. Now you might be like, why the heck shotgun won't work? Because shotguns are directional. They achieve their directionality with two things. First, they're physically designed in such a way. Second, they have what we call interference. This tube you see, it actually does not have anything, it's hollow. So the speaker is I'm saying, basically the driver, quote unquote, the receiver aspect, the microphone is on the other end, and there is a lot of preamps and XLR output and all that management thing. This is the interference tube. Now this tube applies a very resonant cavity kind of thing, and it's a very complicated. People have to do PhD on this thing to figure it out, and that's why you can't make this in your home. Like you can try, and I would urge you to do so, but you will not receive very good results with this. But when you are talking about this cavity, length of this cavity will affect the directionality of your basically shotgun mic. So if you have a shotgun mic that is meant for, let's say, a few feet of work, you want a very narrow kind of thing, so your shotgun mic will be longer. But if you are talking about somebody very far away, you don't want it. Why? Because if you move the camera a little bit, let's say I'm not directly in front of my camera because rule of thirds, I'm like a bit off, the shotgun mic, which is very narrow pickup, will only pick up sound coming from here, but I'm here, it's not gonna pick me up at best quality. So for this reason, we select interference tube of whatever you want. How the heck you gonna select it? You don't. You simply say, I want a shotgun mic with 30-degree pickup. I want a shotgun mic with 70-degree pickup. Basically how wide that is, nothing more than that. And if you find something similar, let's say you Sennheiser itself is selling you, let's say, a 30-degree pickup, 40-degree pickup, or 50-degree pickup. All they're gonna do internally is simply change the length of this tube. That's how you're getting it. And all these patterns, nowadays many other things are there, like a Razer microphone or USB microphones which are along there, and they can allow you to choose basically which pickup pattern to use. How the heck they are doing it? Very simply, you have electronics and cavity. Cavity is the crucial aspect here. This is why sound engineers actually have to need engineering degree. So that interference tube, basically that's one way of using it. If you have two cavities done correctly, that gives you a noise cancellation microphone. And the aspect of noise cancellation is you don't have to use electronics for it. It's not Bose noise canceller where it's receiving the sound and processing it. It's not like that. It's generally used for, let's say, avionics. It's crucial for basically air traffic controller need to hear the pilot. They cannot be like, oh, the sound is not working, the battery is discharged. No. So what they do is they simply have two capsules, basically two microphones pointing away from each other, and that gives them figure 8. Now then they design the cavity around it in such a way that a cavity that is near to you receives your sound, and a cavity around from you basically is receiving the ambient background noise. Now because background noise is coming from both sides, the front chamber is also receiving the background side and the rear chamber is also vibrating, they cancel each other out, and only your voice that is unbalanced, because on the back end you are not screaming for the back side, that is received. That's how they make analog noise cancellation microphone. Benefit, it works amazingly. Side effect, the sound quality is really terrible. That's why you always hear air traffic controller and you sound like this is the best you can do. But you have to understand, if you hear the background noise, you'll be like, dude, I can hear you. Like, if you will have physical hard time talking to each other. That's why you see in the movies when the people are in helicopters, they have to have the headphone, otherwise they will not be able to talk. You need to do that. So each, and again, even in this scenario, each of them have their own use. That's why some people choose figure 8. Sometimes people use ultra directional, like a microphone, basically shotgun. Sometimes super cardioid. Each of them have their use. Each of them have their advantage. So choose wisely. So this was my attempt on taking care of sound aspect, because I have taken care of the video aspect, but I haven't touched on sound. So I want to do more of the sound in the future. So I hope you liked it, learned from it. In that case, please leave a like, click the app that are shown in this video. That will directly help me. And if you didn't like it, don't worry about it. You can press dislike. I would urge you to press it twice to show me your extra disappointment. And please leave a comment, because I reply to all of them. Please subscribe, press the bell icon if you're free. And as always, thanks for watching.